Hello, everyone. Welcome to a brand new edition of our NGI Talks. Let's wait a couple of minutes for the people to be able to join, and we will start the debate right now. Well, I think almost all the attendees have joined now. Let's start this new session of our NGI Talks. It has been an intense year so far with our NGI Talks, this 2021. Today is the 3rd of February, and we have already held 3 NGI Talks so far, and that's great. Let's keep it up. Thank you all for joining us today. My name is Marta Albujar. I am the marketing lead for the NGI initiative, and I'm just going to quickly introduce the talk today on cybersecurity for a safer internet with our experts Dirk Jumpertz from EURid and Cristian Hesselman from SIDN Labs. I will keep my part very short, since it's going to be our NGI Ambassador Aljosa Pasic who is going to moderate this interesting debate about cybersecurity for the next generation internet. Please, throughout the session, feel free to drop your questions on the question box, and we will go through them at the end of the session. So let's start. Panelists, the floor is all yours.
Thank you, Marta. So as already, I will skip the introduction. Marta did it excellent introduction, so we will move directly to the questions. My name is Aljosa Pasic. I'm a technology transfer director in Atos, and I don't know, Dirk and Cristian, would you want to say a few words about yourself?
Sure. My name is Dirk Jumpertz. I am the security manager at EURid, the .eu registry operator. And my main focus these days is mostly on security governance, cybersecurity governance, and awareness and policy making.
Yes, and Cristian?
Yep, so my name is Cristian Hesselman. I'm with SIDN. We're the registry for the .nl domain, so that's the Netherlands. So we have a similar role as Dirk's organization, but for a different region or a different country, if you will. I'm responsible for SIDN Labs, and we're the research team of SIDN. And basically, we're a team of 13 people collaborating a lot with universities doing applied research. So that usually means large-scale measurements, prototyping, and that sort of stuff. And we basically do that in 3 different areas. One is network security. So that's really about the DNS, BGP, and that sort of thing. Then the other area is what we call IoT and domain name security. So that basically has to do with domain name abuse, how to detect that and how to resolve it. IoT security, so how do we detect compromised IoT devices, for example, and how can we mitigate DDoS attacks that stem from these devices. And then the third area is what we call secure trusted internet infrastructures, which is basically looking into the next generation of internet infrastructures for society. And I'm also a associate professor at the University of Twente 1 day a week.
Thank you, Cristian. Okay, so let's move with debate, with discussion. We will start with the topic of digital sovereignty. It is very fashionable these days, and there are many definitions. So I will ask you, what do we mean in Europe? I mean, there is, especially in political talk, there is a lot of talk about digital sovereignty and how to reconcile this political vocabulary with reality, technical reality. What is your stand on this? Do you want to start?
Well, yeah, sure. I'll take a stab at it, Aljosa. Thank you. Yeah, so digital sovereignty. When I first heard the term, it kind of made me shizzle, because I thought, okay, what are we talking about here? And I had the immediate association with, sovereignty of countries and states and that sort of thing. But later on, I learned that it's really different, and maybe the better term would be the digital autonomy. Because I think that in the end is what it's about, that companies and individuals and societies at large have an infrastructure, a digital infrastructure that enables them to shape their own lives, their own society, and decide how they want to organize, use, and structure the digital infrastructure, rather than other people doing that for them. So autonomy for me, digital sovereignty for me, is being in control of one's destination, or at least being able to organize your society the way you want it. And I think that's currently under pressure, because we have, let's say, an increasing amount of our digital network infrastructure, or cloud services, or AI software components are being manufactured and operated somewhere else, so outside of Europe, for example. And ultimately, in my opinion, it's a conflict of public values, right? So the United States, for example, or China, they might have different values than we have here in Europe. And if you want to really control those public values, then you also need to be, to some degree, have insight in and control over your digital infrastructure. And to me, this does not mean that you need to build everything yourselves, because that's impossible. We simply cannot do that in Europe, and neither should we. But you do need the mechanisms to be able to understand what your digital infrastructure looks like and how you can influence it, either through technology or through regulation, for example. So to me, that's what digital sovereignty is about: having the means, both technical and based on policy, to be able to be in control of your own destiny, if you will, to be in control, to be able to shape your own society.
Yes, and when we talked, Dirk, when we talked a little bit before, you mentioned that cybersecurity relies on 4 pillars: technology, training and awareness, standardization and certification, and regulation. In regulation is where Europe stands as a superpower. Let's say we have GDPR, we have NIS1, NIS2. Strategy, we have a lot of strategic initiatives, digital single markets, etc. But then we use a lot of technology in the supply chain from outside of Europe, and we use also a lot of standards. You mentioned ISO, which is one of the most used standards in security, ISO 27000 family. And how can we reconcile these 4 pillars, where it's, as Cristian said, it's impossible to have only European technology, and also in standardization we need to rely on international standardization, and then still we have pieces of Europe-oriented regulation.
Yes, it is I think it's a very complex matter, and if you look at the IT industry in general, you see something that is quite unique in the industry. That's one of the things that is very difficult to find, is competition in this industry. So there is only like one Facebook, there is like one Google, and even though there are other alternatives that try to do something, like you have alternative search engines like DuckDuckGo or like Bing, we still see that Google is the main search engine. So there is a big challenge for the world to make sure that all that centralization and that consolidation that goes to one larger party that does the technological innovation can be counteracted. And I think Europe is doing a really great job, because it's focusing on other aspects that have been traditionally a little bit forgotten in the IT industry. Let's not forget that the IT industry is a very young industry. If you compare it with other industries, like for instance the car industry, that industry too had to go through an entire chain of changes to make it more safe and to make it more secure. And I think we are still at the beginning of that change, of that metamorphosis. What we see is that we have heavily invested in technology. We have plenty of technological means to fight cybercrime and to improve our information security. but we lack a lot in education and awareness. A lot of people do not know how to manage their devices. Now, if you take the parallel with, for instance, with the car industry, back in the day when I remember my uncle, he could just go to the municipality and get his driving license, which is for today's children or today's youngsters completely impossible. We are like, oh, you have to go to school and then you can get your driver license. So you see that there has been a lot of changes that happened to make it more secure and more safe. This is not happening yet. We see, on the other hand, initiatives like, for instance, from the European Commission, where there is the Cybersecurity Act, which believes that we should have certification standards for IT services, IT products, and IT processes. And the idea behind this is very similar to what we already have, for instance, in electrical gear and electrical apparatus. So if you buy something or you want to put something on the European market that is electrical, you have to go through an entire certification body before you can actually do that, just to prevent that people do not get electrocuted at home. This doesn't exist yet in the IT business. And the European Commission tries to do this with the Cybersecurity Act. Unfortunately, it is not a mandatory certification system. The certification system still has to be put up by ENISA, but already it is a very interesting and a very important first step. And so I think from those 4 pillars, we have a very strong technical pillar. We have a weak, still growing educational and awareness pillar. We have very interesting initiatives in standardization with ISO 27001, but also industry-led standards like the PCI DSS standard, which is specifically for the payment card industry. And then there are some other standards also, for instance, in the health industry. And then last but not least, and this is quite new, because if you think about it, the GDPR is from 2016 and was actually applicable since 2018. So it's a very, very young law. And for people, we all know now that we have to click like crazy people on consent buttons on a website for cookies. But the reality is that the GDPR does a lot more than that. So I think all things are starting to evolve, and I believe it's in a good direction. When we look at sovereignty, that's a big challenge, of course, because we see that the technological pillar is based in the United States. Most of innovation happens in the United States. There are other innovations also happening. A lot of innovation is happening also in China, but that is not exported to the rest of the Western world. A lot of innovation is also happening even in Russia. Unfortunately, sometimes more innovation in the cybercrime world than in the other world. But you see a lot of these innovations happening all over the world. In Europe, it is a very, very spread story. It goes all over the place. You see very interesting initiatives in every single member state, where you see things very well done, for instance, in the Netherlands, but also in the Czech Republic, where there is quite interesting initiatives, but they have a very hard time in getting beyond those borders of the member state. And I think if Europe can help a little bit in making these more visible to the rest of the world, we can get a more balanced world where technology doesn't only come from the United States, but is also growing in Europe and actually nourishing in Europe.
Okay, thank you. Thank you. I'm glad that you mentioned also certification, because the next topic or next question that I have is related to it, because we are hearing more and more about attacks on so-called supply chain attacks. So we have pieces of equipment or software that can be certified, but then we have the problem of concatenation or composition of these components, and how to achieve end-to-end certification, because many components will have certification with different time span and maybe from different providers. I don't know. So what do you think? Each part comes with its own risk. The audit or certification is done statically at fixed point in time. So what is the way to deal with this, the end-to-end supply chain security?
Maybe I'll pick this one first. I think the most recent case of the supply chain problem is the SolarWinds data breach. And it's not new. I mean, something similar happened a couple of years ago with the NotPetya ransomware attack, where in Ukraine a software supplier was hacked and a patch was modified, and in such a way that it infected quite a lot of really large organizations. the kind of attack that has been shown here, where the supply chain is infected or the supply chain is attacked, is extremely difficult to control. I mean, if you get into the heart of an organization and you can actually use all the mechanisms that are in place to protect the intellectual property, to protect all the software components that have been developed, and you piggyback on this. I remember there's also been a case with the SWIFT network where banks were penetrated, banks were hacked, and they were using the SWIFT network to exfiltrate money. When you see this happening, it becomes extremely difficult to build a trust model for the supply chain. Of course, we can start with basic security. We can say, you know what, your entire supply chain has, for instance, to be ISO 27001 compliant or certified. Will this help counterattacking these kind of, or will that be an effective countermeasure for this kind of issues? I fear not, because this is a completely different type of attack. So managing your supply chain is extremely difficult. On the other hand, of course, it is also a very broad and complex matter. So I also see that a lot of supply chains are trying really hard their best to do the right thing. For instance, in our case, we are looking at domain name registrations, and we are trying to see if these domain name registrations could potentially be used for malicious purposes. And if we believe that they might be used for malicious purposes, we will hold them back until we have an identification of the owner of the domain name, which is part of our abuse prevention and early warning system, our APU system. But that's one little part of the equation. And I know that a lot of other parties in our ecosystem are trying to do very similar things to try to get a way around or try to get that supply chain under control. But I think, and I fear, it's an extremely difficult and complex matter that is not going to find an easy way around, an easy way to fix that problem. Especially when you look, for instance, at the NotPetya attack. There's one thing that we have to think about in cybersecurity. You have on one side the cyber criminals, and on the other side you have the state-sponsored attacks. They are using the same methodology and the same techniques, but you don't always know who is who. And a very good example is the NotPetya attack, where in the end cybersecurity researchers have concluded that this was not a cyber criminal operation, but this was a cyber state attack. Cyber states have infinite resources, and to ask this to the business, to the economy to try to fight this is extremely difficult. But I think we should all chip in and do our best to make sure that we reduce the possibility of these things to happen.
Thank you. Cristian, if I can connect this question to the topic that I know that you are working on it, responsible internet, and the extensions, security by design extensions to internet, and what is your opinion, and can you tell us a little bit about this concept of responsible internet?
Yeah, maybe first getting back to what Dirk just said, I think I'm not an expert on supply chain attacks or security, but I think that starting with basic security is important, but I think there is a second layer that you will need in general, which is trying to somehow map out the dependencies in the supply chain. So, for example, if we speak about domain names, we have a tool developed at SIDN Labs where we can map out the dependencies between different domain names in the .nl ecosystem. So if we know that a certain domain name is being used for malicious purposes, so let's assume that it has a rogue certificate, then we can discover other types of other .nl domain names with the same rogue certificate. And so we can group them together and try to map it out in a network, if you will. So that is not only about, let's say, securing the individual components of supply chain, but also to mapping out the dependencies so that when something breaks, you know where else it's going to break. And I think this is also maybe the bridge into that responsible internet that you refer to. So that's a new concept. That's something that doesn't exist yet. And it's something that we kind of developed a few months ago. And the thinking there is that if you want to build an internet that you, let me take one step back. So if you look at the internet from the past, you would run email applications on top of it, and things like web browsing. But increasingly, the internet is being used for different types of applications that have a interaction with physical space. like energy grids are being connected to it, autonomous driving, remote controlled health robots and stuff like that. So there's an interaction with physical space. And this means that you need higher levels of trust from the network than you would potentially need in the past. So only having basic security in there, like, okay, I have end-to-end encryption, might not be sufficient anymore. Because if you follow a path on the internet and it has like 5 or 6 networks that your data passes through, maybe for some applications, you also want to know what are the security postures of each of these individual networks. And that's something that the current internet cannot offer. Okay, so in that case, you will, at least that's our thinking, you will benefit from having a network that is more transparent. So you know what the dependencies in the network are when your data flows through it. And you as a user of that network, if you are an individual user or a smart energy grid or something, you may want to know what these properties are of the network, and then you can decide, okay, I want my data to be sent through this path through these networks, or I want it to be sent through the other path using the other networks. Okay, so that will give you more transparency, but then you will also need a little bit more control, because if you look at the current internet, then you cannot really applications cannot really decide what route they want to take through the network. Okay, that's something that's being done almost autonomously, I would say, in the routing system, so the BGP peer-to-peer system. And with this new network that we're thinking of, applications would have more control over that. And this is not useful for every application, so an ordinary user would probably not care. But safety critical systems, they would probably care how they would send their data through the network. And that's what we call the responsible internet.
As an example, I can say, for example, for those that are listening to this webinar, example would be that they are able to choose, actually first to see that we use GoToWebinar, where the server is from GoToWebinar, which flow where the video stream flows, and they would be able to choose which endpoint or data center they are using. So this would be example, right?
Yeah. So that there are actual practical applications there. So a while ago, when everyone started to use Zoom because of the COVID situation, there were requests by users and governments that they wanted to know where the video streams of people were being handled. Were they being handled in Europe, or were in the data center in China, or in data center in South America? Folks wanted to know. And then Zoom, they provided this as a service to their customers. And our proposal is to use that functionality, but kind of build it into the network so that it's available for every application and not just for Zoom.
Okay.
So that's a good example. Yeah.
Good. Dirk, do you have some other example? What about the abuse prevention, or do you have some example that you would like to talk about?
Well, like I said a little bit earlier, but maybe it wasn't very clear. The APU system that we've built is based on 2 components. It's very easily said. It's a black box that is in the registration flow. And whenever a domain name gets registered, so somebody wants a domain name, they go to a registrar, they register their domain name. And then what happens is that once they have entered all their information at the registrar level, so where they typically buy their domain names, then a part of that information is transferred to the registry, because the way that the DNS works, we have to know certain things to make sure that the domain name actually functions. And so when that happened, once we have received all that information, then we put it normally in the zone file. And the zone file is a big DNS database is basically the DNS more or less database, where in the end you can actually find all the domain names in our space, in the .eu namespace. Now, what we decided to do is we wanted to hook into that flow. So when we see something strange happening with a specific domain name that has been registered, or we see patterns from previous registrations, for instance, domain names were part of a spam campaign or a phishing campaign, and a new domain name is registered with similar characteristics, we can hold it so that it doesn't get into the zone file and it cannot be operated. It won't work. And this actually enables us to block some of the malicious actors on the internet for specific threats. Now, that APU's concept is partially based on machine learning. That's one of the components, and it's also based on a rule-based system. So it uses the best of all worlds to be able to make a correct decision on what's going on with specific domain names. It has been heavily used during the Corona pandemic, where we were looking into potentially domain names that were related to the Corona outbreak, but as well as people that would be abusing the situation and trying to do all kind of stuff. And so this allows us to interact with this and prevent, in a certain way, malicious actors to do their bad things. So that's one of the things that we've heavily invested in over the last couple of years, and we are still investing actually in that component and in that process. And maybe there's one last thing that I would like to add to this story. We all know that Estonia in some years ago had the unfortunate privilege of being one of the very first countries in Europe to be attacked by a foreign state on the cyber level, and they decided to fix the problem in a way that afterwards I haven't seen that anymore. So their system, or the way that they are protecting their system, is to look at integrity. So very often when you're talking about information security, we are talking about confidentiality. We encrypt all kind of information so that people cannot read into it. But integrity is also quite important. So if you know every single modification transaction that happens on something, and you can actually request that, and you can actually look into that, then you can actually verify if something happened during that modification, during that process, that would potentially be not acceptable. In Estonia, they went that far that if you are reading somebody's ID card, that leaves a trace. And that trace can be requested by other systems. So it's not like it's super confidential, because they used back in the day, they used blockchain technology to do that. So it's already using cryptographic technology to protect that. But it was actually possible then to verify all the transactions, all the different actions that happened on an entity, something. Now, imagine that you take this in the supply chain. Imagine that you would put some system on top of it that when you are building software, that all the transactions, all the changes in your software would leave an external visible view on the integrity of the files. Then it would be possible to see that some things have changed that were not supposed to be there. So integrity is a very important part of cybersecurity, and very often it is forgotten. People always think about, oh, confidentiality, we have to encrypt everything, we have to make sure that nobody can look into it. But on the other hand, making sure that what I sent you is actually what it was supposed to be, is also very important. There's plenty of technology that does this. I mean, you can do that for email, for instance, with SMIME and PGP. You can do that for plenty of other things also, but it's not yet built in the foundations of the internet, that when something is moving, something is happening, that we actually can verify that the modifications, changes, alterations that happen on something are actually the ones that we wanted to. And to finalize this, we all have trusted channels with our partners. For instance, at the registry, you have a trusted channel with your registrars for all the registrations. And we all know the concept of the zero trust approach that we very often use these days to end users. So the end user shouldn't trust anything, and companies shouldn't trust any kind of interaction with their infrastructure. But we definitely have to go that far that we can actually verify that any transaction that happens within a system, within an ecosystem, is actually a transaction that we can trace, that we know that it was supposed to happen. And once we can do that, I think we can solve quite a lot of the problems we see today.
It's interesting you say that, Dirk, because let's say the responsible internet, that concept that I just spoke about, is exactly about what you said, that you can, if you send your data through the network, you can verify afterwards how your path through the network, what it looked like. So if it traversed, let's say, untrusted networks or trusted networks, where trusted, of course, is a subjective notion that depends on who's using the network. And similarly, you could record transactions that were made on network infrastructure, for example, where they updated with the latest security patches. Where is there a third party that a certain network operator has just contracted to outsource part of its operations do, stuff like that. So it's kind of a metadata layer, if you will, that keeps track of all the transactions that occur at the infrastructure level and at the data flow level, so to speak.
I think just to give a little last remark on what Cristian said. I think from a technological perspective, I mean, there's a lot of bright people working on the Internet Engineering Task Force and in all the stewards of the Internet. So technologically, we are fixing this problem. The problem is that very often we see that the implementation of all that technology. I'm going to give you one very simple example. There is something called BCP38, which is a standard that actually would solve a lot of the DDoS problematic. Yeah. But nobody wants to implement it because it's too expensive. And so what we see is that some organizations implement BCP38, but if not everybody implements it, the DDoS attack problems will not disappear. And that would be actually very good. And that's where we have these 4 pillars. And we have to make sure that people in technology also explain to people into policy making what this BCP38 is all about in layman's terms, so that everybody understands it. And then go one step further and say, you know what, we are going to enforce it. Just like we enforced a safety belt in a car, we are going to enforce certain things on telecom operators, on anyone who is doing something on the internet, who manages a part of the internet. We will enforce these things. And that's the really sad part. I mean, Cristian and myself, we are both in the DNS world. We have DNSSEC. The implementation of DNSSEC is not good. This is the security extensions on DNS. And unfortunately, we have to do all kind of wizardry to get some pickup of that protocol. And again, we need the policymakers to understand how it works, and then we can push it forward. So it's literally cybersecurity is about these 4 pillars. And technologically, we have done a wonderful job. I mean, we're there. I mean, we know how to fix the problem. But we need those 3 other little pillars that are today are very small pillars to really, really grow. And I will shut up.
Thank you. It was really excellent discussion. And however, I would like a little bit to move it from the advanced user to common user. So because all of this concept, well, at least the most of this concept is really making assumption that user has inside control, but also the knowledge and to deal with this complexity. So we know that the common users, I'm talking about the grandmother type of user, which is using is not really aware of many of these mechanisms. Sometimes they are too complex, and we have many examples where the user is accepting default configuration, which might be vulnerability. So they don't like to reconfigure connectivity parameters. And we have examples recently, for example, DNS over HTTPS, which is doing the thing that is coming. Some browsers are coming with the default servers, centralized default servers. So what do you think about this? About how this can be this vulnerability can be done for common users?
Well, when it comes to users, in my opinion, I mean, it's what Dirk said at the beginning. The computer industry or the networking industry is actually kind of young, and we're going through the same phases as previous industries went through, like cars and trains and stuff like that. So transport systems. And this also means that as technology is maturing, some of them disappear from their end user's radar. Right? So when you jump into a car today, you don't need to know how the engine works, whereas 100 years ago you had to. So I think the same thing is happening to computer systems and to distributed digital infrastructure. So people know what they see on their screen, they know their iPhone, they know the applications that they use, but they don't know, and they don't need to know what's underneath. So they don't know the operating system, they don't know the network. The downside of that is that the network is not a business incentive. So because organizations don't get any revenue from them, they might not have that much incentive to implement things like DNSSEC. Okay, so because there is no user demand, people just expect everything to work. Okay, so I think there's a difference between when you talk about user friendliness and users being able to work with digital systems, there's a difference between applications and the network.
Yep.
And as for DNS over HTTPS, well, Dirk probably knows much more about it than I do, but I think that in itself it's a good technology because it encrypts the DNS traffic between your phone or your PC or whatever, and the next hop onto the internet. But you also see that sometimes it's being used it can also become a point of centralization, okay, where certain large players collect a lot of data about users. And the somewhat scary thing there is that when you're an organization like SIDN or EURid, you see some of that DNS traffic. But if you're one of these resolver operators that operate DNS over, they use DNS over HTTPS, you see all the traffic from the clients. So it's much more fine-grained in terms of folk you can trace what you can do with that. But I'm sure Dirk has an opinion there too.
Well, over DNS over HTTPS, I do have very strong opinions. I find it really sad that HTTPS has become the default protocol for basically anything and everything. I wouldn't be surprised that this conference even happens over HTTPS because it's handy, it's easy, but HTTP was never designed or developed to do that kind of stuff. But that's another discussion for another time. It is extremely difficult indeed for people to understand how devices work. But on the other side, again, technology is really doing its job in creating almost a seamless and even secure experience. Unfortunately, it's not for all the vendors. If you look, for instance, in the mobile system ecosystem, there you have the two big players, Android on one side and the iPhone, Apple on the other side. Apple has a very closed ecosystem, whereas Android has a very open ecosystem, and we see a lot of issues both in the Android ecosystem as well as in the iPhone system. But what I did notice is that you notice that both parties, depending on the level of implementation and the price level of the devices, you see a lot of effort going into user friendliness, but at the same time also about security, which is a good thing. But then again, not everybody is doing that. If you're looking at the IoT market, then you can find very cheap devices. And I had the opportunity to give some courses at the University of Pisa on cybersecurity for non-technical people. And I had this little show where I would show some pictures of IoT devices and ask which obscure brand it was. And very often it were AAA brands. And people were surprised that you would find these kind of things like a Fisher-Price teddy bear that is actually an IoT device that communicates with the internet, sends images and sounds of your children to some server somewhere, and nobody knows about it. And how can you expect that a parent who managed to get that thing online because he pushed a button and another button on his router and then suddenly magically it worked, how can you expect that this person would know that this thing is secure and that the data that is being sent about of his children is secure? They can't. So on one side, you see technology doing really hard its best to build secure systems. And when we're looking at traditional IT, and when we're looking at operating systems, I mean, we went from the old Windows systems to Windows 10, and Windows 10 is much more secure than ever. When we're looking at Apple's ecosystem, these are all very secure systems, but this is their main focus, to create an environment where you can be productive in a secure way. But if you then turn around and you look at the other markets, you see a completely different ballgame. You see all different types of standards, and everybody does something. And there, very often, you see that it shouldn't be too expensive. People are not prepared to invest a lot of money in these things. They have a very quick time to market, and in the end result, you end up with devices that are by definition insecure. Unfortunately, some of these devices, they are industrial devices. So Cristian already mentioned smart cities. But a couple of years ago, I was on a hacker convention in Luxembourg, and there was a guy who did a presentation about how easy it was to hack seismic sensors, the things that are in the sea, the things that are everywhere, that are measuring the Earth. And he said it was amazing how easy I could hack these things and actually make them measure something that wasn't there. Can you imagine an earthquake I don't remember exactly how the scale of Richter works anymore, but the maximum scale of Richter happening in the North Sea, because there are actually these devices in the North Sea. So we definitely need something else, because obviously some part of the IT industry is doing really hard its best to make it secure and user-friendly, but then there's another part who clearly doesn't know how it works. And so there again, we need that fourth pillar, the pillar of policy. And I think if you look at again what Europe is doing with the Cybersecurity Act, where there is a certification, it's very in its infancy, but maybe that might be already the first step to go further, where devices that are sold on the European market have a minimal set of requirements to make sure that they actually are sufficiently secure, and taking into account that security is by design, privacy is by design, and user-friendliness is also by design. And we know it is possible. I mean, when people think about it, they can actually do it. So there is hope. Yeah. There is hope.
Yeah, and there's current work on that, because I recently spoke to the Dutch telecoms regulator, and they are involved in an extension of the RED directive, the Radio Equipment Directive, to piggyback cybersecurity requirements onto that regulation, so that all devices in the European Union have to adhere to some sort of minimum level of cybersecurity. So that's already ongoing work. And I think what's also important then, if you start, well, two things I think. So it's also important when you talk about IoT for consumers that consumers get some sort of idea about what the security of their product is, because if you buy a camera or you buy something else at your local shop for equipment, then usually it doesn't say anything about security on the outside, right? So you need something, I think, to have some sort of what they call, I think, explainable security, saying that, okay, this is your label. So there is for houses here in the Netherlands, there is a scale from A to F, how energy efficient those houses are. And you might want to introduce something similar for the cybersecurity of IoT equipment. So from A through F, with A very secure and F is, well, it's your luck, all risks are on you, something like that. And I think that one other risk there is that IoT devices are getting smaller. So in a couple of years' time, you can imagine that maybe your doorknob also has a sensor in there, or something in your closet has a sensor in there. So they are getting smaller. You don't even see them anymore. And as a result, compromises of those IoT devices might also go unnoticed. And I think that's a challenge, because in that case, the explainable security with the labels probably won't work either, because the sensors are being shipped with the door, for example. So I think that the miniaturization of IoT devices is an important challenge as well.
We have so much to discuss. I'm sorry that the time is almost is running, and time is almost finished for the conversation. So we have time for one last question. I will try to make it big one, to aggregate a couple of things, because you mentioned so many interesting things about regulation, for example. So we have now ongoing NIS 2.0, Network Information Security 2.0 directive, which is about the essential entities and important entities, and your organizations are in this scope, falling in the scope of this directive, and which means that you will have also to take appropriate and proportional, now using the wording from this directive, appropriate and proportional technical organizational measures to manage cybersecurity risks. So the question here is about collaborative. What can be done with in collaboration with other organizations? Because obviously you are responsible as either as essential entity or important entity. You're responsible for your part, and you might even be paying some. You have to comply with directive. But then there is the part which is on collaborative internet security, with working together into, for example, the Cristian is working in anti-distributed denial of service coalition, anti-DDoS coalition. Did I say it right?
Yeah, you did.
So what can be done in regulation and also in this the part of collaborative security?
So oh, sorry, you go ahead there.
Go ahead, Cristian. Okay, thank you. Right. In the registry business, in the top-level domain business, is a unique world, in the sense that all the registry operators, they are more or less colleagues of each other, and we work closely with each other. So, for instance, in Europe, you have Center, which is a European initiative based in Belgium. It's a non-for-profit organization where all the European and even non-European registry operators are member, and we exchange all kind of information, including R&D information. We show each other's work on R&D. We show each other's work on technical innovations. We show each other's work on security, and we try to help each other in getting more mature in security or in understanding some of the technologies that exist. So that is, and I know that this is quite unique. I know a couple of other sectors that have something similar. The financial sector has something similar for obvious reasons, because cybersecurity is also quite an important factor for the financial sector, and if you don't get it under control, everybody has a problem. So there's already a lot to be said, and within that group, we already have been discussing, can we share more data, and which we actually already are doing. Of course, we have to keep in mind that there are some legislations that prohibit the usage of certain data, like personal data, to be shared. There are some exemptions on that thing, but okay, we have to be careful with that thing, and we have to figure out a way to work with that data. But we are trying to exchange as much data as possible, and the NIS, not the NIS2, but the NIS is also helping a little bit on that, because it puts cybersecurity as an important topic on a country's level. Every country is supposed to have a cybersecurity center and do something with cybersecurity, organize it, and make sure that the operators of essential services and the critical infrastructure providers are actually regulated with regard to cybersecurity. And by doing this, they also collect a lot of information and data. And so these organizations, these sectorial authorities, they're starting to get and understand the differences between the different organizations. And one of the questions that I've asked to our regulator is like, okay, will you share that information? Because if you notice something happening with one of your constituents, then maybe it's quite worthwhile to share it. And they said, yes, of course, we are going to do that. We are going to coordinate that. So there are things moving, and this is one of the positive things about the NIS, is that you start seeing a collaboration on higher level, where through different sectors, people are starting to communicate with each other. It's a first step, but I think it will go even further. And I know, and that's the reason why there is a NIS2 already, that not every country has implemented in the same way. For instance, in the Netherlands, I know from my counterpart at SIDN that he had a lot of headaches in dealing with the NIS, because it's much stricter, for instance, than in some other countries. And so that's the reason why there is a NIS2 now, to harmonize that implementation over the different countries and to make sure that we are comparing apples with apples and not apples with pears. So I think there's a lot of positivity going on, but again, it's in its infancy, and step by step we will be getting there. Cristian, you want to say something?
Yeah, I can confirm that. So what you said is totally right. The DNS industry is, I think, different. It's actually quite collaborative. So for example, we have like 250 CCTLDs on the planet, so country code top level domains, and they actually have a shared medium, a mailing list somewhere, where they exchange cybersecurity information on security incidents, for example. So that's a global list, in addition to the European interactions that we have through Center, what Dirk spoke about. So in addition, I think that we're also involved in this initiative called the Anti-DDoS Coalition, which is in the Netherlands, and it's partly in the Netherlands and partly in a European research project called Concordia. And this is basically one of the mechanisms, I think, that you would need to implement the policy that Dirk spoke about. And it's a system where organizations, so in the Netherlands, it's governments, it's ISPs, it's the Amsterdam Internet Exchange, it's academics, so all kinds of different banks exchanging information on DDoS attacks. At least that's the goal, right? So we have a system that can do that, and that we just need to install it in the networks of the various members of the coalition. And this is something that's challenging, because sometimes people need to make changes to their operational infrastructure to accommodate for such a system. And of course, that brings in risk. So if you're a large company with a lot of network infrastructure and you need to put new equipment in place, that usually takes a bit of time. But I agree that with Dirk that the attitude of all the organizations involved in this particular initiative is very positive, and they all agree that this is important. And in addition to exchanging information on DDoS attacks, what we do in this coalition as well is that we carry out collaborative DDoS attacks. So this means that with that group of 17 organizations, we set up drills where we kind of DDoS each other and try to find out what breaks if you get hit by a DDoS attack. And that's important because that gives you the, let's say, the operational practice to kind of go through what you need to do when you get hit by a DDoS attack. So that's at least as important as getting the real-time information on DDoS attacks from other organizations. So I think that's a very cool example of collaborative security.
Yes, definitely. Okay, so I think we have a couple of minutes left. Marta, are there any questions from the audience or?
Yeah, but we only have one question, likely for you, because I know you have to go at 4. So I will just read this. This question is related to digital sovereignty, and it says, do you think that an excess of legislation or prevention might prevent innovators from appearing and thus prevent competition? And how should we deal with that?
Dirk, can you say something sensible there?
I think it's a traditional fear that some people have, that a lot of legislation might stifle innovation. I don't agree with that. I think it's actually the opposite. It's understanding the legislation, looking at it, and see what it can do for you. So I don't think that innovation. I don't think that innovation will be stifled by excessive legislation. Of course, legislation has to be proportionate, and that's what we see also with the NIS2. There's a lot of things that got into there, which created some questions, especially in our sector, in the DNS sector, and we were wondering, like, okay, from where does this come from? So potentially it can be quite disruptive. But I think in general is that if you look at what these legislations are trying to do, and I'll give you one example. GDPR is actually a very good example. Today, people know the GDPR because they have to click on the consent buttons for cookies. That's what they think the GDPR is all about. But the GDPR is actually a very different beast. The GDPR is about us as being the data subject, as the law calls it, knowing what happens with our data and not accepting that somebody just does anything with the data that they collect. To give you one practical example, if an insurance company finds it a very good idea to give you a biometric, to give you a health device, and then put, say, web service somewhere where they collect all that health data and then use that to modify the policies that they have and the price you pay for your insurance, that is something that the GDPR says, no, you cannot do that because you're using data for legitimate purposes. So I think that's the spirit of the GDPR, and that can really help us as individuals who really don't have any control over what happens on the internet with our data. Unfortunately, again, baby steps we are taking. We still need to figure out a way forward how to really deal with the GDPR. And a lot of people get completely spooked because they think, oh my God, I'm going to get fined because I'm using an IP address. They should read the GDPR a little bit better. But my conclusion is that laws don't necessarily stifle innovation. They can actually also be a very good leverage to create some very interesting things. We have to be careful, of course, for small and medium enterprises, because they can occasionally be spooked away because of that legislation.
Yeah, it can actually, I think that regulation can actually create a level playing field, so that if you would say, for example, everyone has to implement DNSSEC, then all companies need to take the costs rather than just the few that want to do that voluntarily. So I think it could also have, let's say, a stimulating effect on security mechanisms. And in addition, I think that what you said at the beginning, Dirk, is that it's also an issue of the maturity of the industry, right? The IT industry and the network the internet. It used to be unregulated. It was like the Wild West, you know. And the same goes for the car industry, like 100 years ago. But we need that will change, because the societal impact of the internet and clouds and AI algorithms and what have you is so big that you cannot go without regulation. So you must have it. And the cars are continually being innovated. I mean, we went from cars that you had to start manually to combustion engines to now electrical cars. So there's innovation there.
Okay, thank you to both of you. I really like the metaphor with the car industry and this discussion. Hopefully we will have another opportunity to go to discuss it, especially because in a car, when you have a problem in your car, you can damage another car on the road. So this collateral effect and damage is similar to what happens on internet, where something vulnerability on your device is actually damaging the other people.
Yeah.
Thank you, Marta.
Yes, I have just some final comments. I saw there was some last minute questions. I suggest you to, I drop a link on the chat. It's the NGI community. We can continue the conversation there, because actually our panelists need to go now. Just a quick reminder today, I would like to remind that our next NGI talk is going to take place at the beginning of March, and we will confirm the exact date and hour in the couple of days, in a couple of days. And yeah, just follow the community and you will have all the information there. It's going to be with another NGI ambassador, Cyber Voluntarios, the association Cyber Volunteers. So I hope you all are there too. And yeah, as I said, let's continue the conversation. It was really getting very interesting in our NGI community. Thank you again to all of you, and thank you to all our attendees today. And let's see each other in the next NGI talk. Bye. Thank you all.
Thank you.
Thank you.
Thank
you.
Bye.
Bye.
Bye.